Hello,
Hello.
hello. Can you hear me?
Yeah.
Yeah, okay. So today we'll do the last class of number theory for now. This will be about Diophantine equations. Basically, these are multivariable equations. So I'll just give you the definition first. So an equation of the form f of x1, x2, xn is equal to 0, where f is an n variable function where n is greater than equal to 2 is called a Diophantine equation. And here the solution to this equation will be an n tuple. N tuple means a set of n ordered elements. So that will be a1, a2, till an belonging to, let's say, integers. So then these stand for values of x1, x2, and so on, which satisfy this equation, right?
Yeah.
So in general, like there are questions on number theory which come down to solving equations. We'll see some examples and learn from them how we solve such equations. So for example, let's look at this one first. Determine the integer n for which n square plus 19n plus 92 is a square. Basically, when is it a perfect square? Another question like this.
Like uh,
Huh?
I make it some m square and then I move the terms to manipulate and use the
Yeah, yeah. You have to do things like that only. In the first one, you should try to say n square plus 19n plus 92 is equal to some x square. Some x is an integer.
yeah. And
And then hope to manipulate it in such a way that you can try and solve for x and n.
what should I do with the 19n?
Exactly. So ideally, you would like to factorize this thing somehow, right?
Yeah.
Like if you get some product of some factors is equal to something, then you can try to guess the factors and all.
Yeah.
So the problem with that factorization is that 19n and all, right?
Yeah.
Because there is a 19n term, n square plus 19n, like it is difficult to factorize anything. Then the only thing that comes to mind is basically trying to write it as a plus b whole square, n plus something whole square, right?
Yeah.
And try to use 19 there.
Um,
But the
but then,
problem is that it will become fraction.
yeah.
So then maybe make it even, right? By multiplying with something.
Okay.
Both sides of the equation, if you multiply, you can probably make it even.
That's not helping me. I mean,
Just multiply both sides by 4. You'll get 4n squared plus 76n plus 368 is equal to 4x squared, right?
wait, I multiply by 2.
Now, 2 didn't work because 2n squared will not work, no?
Okay.
If you want to make perfect square, 2n squared doesn't work, right?
Yeah.
Multiply by 4, that is better. You're getting 4n squared plus 76n plus 368, right?
Yeah, yeah, yeah. And then it's 2n plus 19 whole thing
Ah,
square plus 7.
is equal to 2x whole square.
Yeah,
So then you can now factorize it by doing a square minus b square.
yeah. N is a -8 and -11.
Um, yeah, those are the two values. You will write down the factors and you will get it, right?
Yeah.
You get two equations and you can solve. Correct. So similarly, try this one, the next one. Next one is slightly easier because factorization is obvious. You just have to figure out the cases.
Yeah, there are many cases.
So how to reduce the number of cases, right?
Yeah.
So that is something that you can think of. Like this is actually 3 power 1 into 2 power 5,
So
right?
like x minus n and the x plus n have the same like odd or even.
Both have to be odd or both have to be even,
Yeah.
right?
So they both contain at least one, two.
Hmm. I think X and N have to be both odd and even, right?
X and n.
Because if, oh wait, the whole thing cannot be odd, right?
Y. The whole wait. You
X
mean x minus n cannot be odd?
and X plus N cannot be odd because this side is even.
Yeah.
So what has to happen is,
Yeah. So like both contain the factor 2.
hmm, both have to be even basically. So then you can start off with 2 and 48, right? Case 1. And then 4 and 24, and 6 and 16, and 8 and 12, and nothing else, right?
Yeah.
Because this has to be greater than this, right?
Yeah.
So now from each of these cases, you'll get one solution, I think.
Yeah.
N should come out to be here, for example, 23.
Just 10, and the next is 5 and 2.
5 and 2. These are your 4 solutions. So sometimes in these types of questions, it is not just enough to factorize. You'll have to think of odd, even stuff like that, right?
Yeah.
Because otherwise there will be too many cases. Okay. Next one is this one. Find all the ordered pairs of integers x comma z such that x cube is equal to z cube plus 721. You'll have to take cases.
Yeah.
One case is that this is 1, this is 721. And then it comes a quadratic in Z.
Yeah, I'm trying to calculate it.
You're getting these two solutions, no?
Yeah. And
The other case will be using this one. X minus Z is equal to 7. And then Z plus 7 whole square plus Z square plus 7Z plus Z square is equal to 107.3.
this one I get Z is equal to -9 and 2.
Correct. Z will come out to be -9 or 2. And then you can find X, right?
Yeah.
So pretty straightforward once you factorize it and solve the quadratic.
That means that the term x squared plus xz plus z squared is must be greater than x minus z.
Uh, must be greater than X minus Z.
Because there are other cases like x minus z is 721.
That also you can try, but what happens when you do that is that it comes out as imaginary, the values, once you try that.
Okay.
The roots of the quadratic will not come real. You should try that, but you will see that it will not come,
Okay.
right? So ultimately, it's about just factorizing and solving quadratics, which is quite easy. The next one is not so easy. Next one is IMO 1986. So it says let D be any positive integer not equal to 2, 5, or 13. Show that one can find distinct A and B, distinct A and B in the set 2, 5, 5, 13 D such that AB minus 1 is not a square. Try to understand the question, what he's saying. So this is a set 2, 5, 13 D.
Yeah.
D is a number that is not equal to any of these three, right?
Yeah.
He's saying show that there is at least one A and B which are different, or two numbers in this set, such that AB minus 1 is not a square.
So it's basically saying that one of the terms 2D 5D and 13D are 2D minus 1, 5D minus 1, 13D minus 1 is not a square. But like 2 times 5 minus 1, 9. The others all square.
Correct, because others are all square anyway. 2 into 13 minus 1, 2 into 5 minus 1, 5 into 13 minus 1, right?
Yeah.
So what we need to show is that at least one of 2 into D minus 1 or 5 into D minus 1 or 13 into D minus 1 is not a square, right?
Yeah.
At least one. So since this is like a statement which is quite awkward to try to prove like this, you should do by contradiction.
Yeah.
Proof by contradiction. Assume all these are squares, right?
Yeah.
That will be better. So you can assume 2D minus 1 is equal to x square. 3D minus 1 is equal to y square. No, not 3D. 5D minus 1. And 13D minus 1 is equal to z square. And from here, try to think of some contradiction.
My first thought is to take differences.
Yes, that is possible. You will have to take that, I think. But from the first one, what can you see? From the first one,
First one.
x square is odd, right?
Oh yeah.
Implies x is odd.
And
Right?
so are y and z.
X is odd.
No. I was stupid.
What? If x is odd number square will be what? Will be what kind of numbers? Try odd number squares. 3 square, 5 square, 7 square. It is always going to be of the form.
Oh, I should take modulo 3 or 4, right?
It is 1 mod 8 always. That is just a fact. You can prove it by induction that any odd number square will be 1 mod 8.
Oh yeah.
Right?
I know.
So what we are getting is x square is 1 mod 8, right?
Yeah.
X square is 1 mod 8. That means 2D minus 1 is 1 mod 8.
So 2D is 2.
Mod 8.
So D
And
is 1 mod 4.
D is 1 mod 4. So we are getting at least this thing, right?
Yeah.
So D is odd, right?
Yeah.
D is 1 mod 4, so D is odd. Now, if D is odd, that implies here 5D minus 1 is even and
Yeah.
13D minus 1 is even, right?
Yeah.
So Y and Z are even, right?
Yeah.
Okay. So far you have done this. Now think of what else can we do from here. You should subtract now what you thought.
So it's like 8D equals
Right?
yeah.
Z square minus Y square is 8D. That means Z minus Y into Z plus Y is equal to 8D. And D is odd and there is an 8 here, right?
Yeah. So
that means Z minus Y must somehow Since z and y are both even, this has to be even, right? And this also has to be even, but someone must be divisible by 4, right?
Yeah, and the other is not.
So if someone is divisible by 4, let's say z minus y is divisible by 4, right?
Yeah.
Z minus y is divisible by 4, then that means z minus y plus 2y is z plus y, right?
Oh, yeah.
And 2y is also divisible by 4, no?
Oh, yeah, yeah, yeah.
So then z plus y is also divisible by 4, right?
So it's divisible by 16, but AD is not divisible by 16.
Yeah. Here you are getting it is divisible by 16, but 8d is not divisible by 16. That is your contradiction. You understand?
Yeah.
So it all started with first understanding that all three cannot be squares. And you have to assume that they are squares and do by contradiction. And then from the first one, we get that x is odd. And if x is odd, now if you don't know this fact, it might be difficult to do this. That if x is odd, x square is 1 mod 8, right?
Yeah.
Because from there only we got that d is odd, d is 1 mod 4 and stuff. So let's, how to prove this, right?
Yeah.
If x is 2k plus 1, x square will be 4k square plus 4k plus 1. This part is 4k, k plus 1, and k into k plus 1 is divisible by 2.
Yeah.
So this is 8 d plus 1, right?
Yeah.
So once we got that d is odd, from d is odd, we are getting that y and z are even, and this is happening, and then we can see a contradiction, right?
Yeah.
Okay. Then let's look at another one. So this is International Maths Olympiad, not so hard though, right?
Yeah. But a little tricky.
A little tricky, but like once you get that idea, then it's obviously not so hard. Then the next one is this one. Find all integral solutions. Integral solutions of x square minus 3y square is equal to minus 1. This is also a little tricky, but it's very short solution if you get the trick. Are you getting any idea?
I'm trying to. Is it? I feel like there's no solution.
Why? Why
Because
do
like,
you feel that?
is that correct answer?
Well, that is correct.
Oh, yeah. Because like, I just x square equals 3y square
Yeah.
minus 1, and then I use because x square is congruent to 1 mod 8.
X square is congruent to 1 mod 8 this side, but that is only if x is odd.
Eh? Oh,
That is only if x is odd, no?
oh yeah, yeah, yeah. I have to consider.
The answer is right, but the logic you have to think about. You have to consider the other case also.
Oh yeah. There's also a contradiction with mod 4.
You're saying if x is even.
Yeah, the x square is divisible by 4.
Hmm.
So 3y square minus 1 is divisible by 4, and 3y square is congruent to 1 mod 4, and that's not possible.
3y square should come as congruent to 1 mod 4. Why is that not possible?
Feels like, wait, not possible, right?
But why?
Because the same idea, x square, y square is congruent to 1 mod 8.
Y square is congruent to 1 for odd, for y odd. Y square is 1 mod 8. Then 3y square will be 3 mod 8.
Yeah, and it's either one mod 8 or 5 mod 8,
Hmm.
so it's not possible.
For even case, it will be 0 mod 4.
Yeah, so the value is obviously odd.
Hmm.
Yeah.
Okay, this is one way to do it. You could also have done this like this. If x square is equal to 3y square minus 1, if you take mod 3 on both sides, you'll get x square should be equal to minus 1 mod 3, right?
Oh,
That means x square is 2 mod 3,
and
right?
oh yeah, but x square is always uh congruent to 1 or 0 mod 3.
X square is always congruent to 1 mod 3 or 0 mod 3. Can never be 2 mod 3, right?
Yeah.
So that is a contradiction. So sometimes in these equations, it is good to take mod some number and then see what is happening, right?
Yeah.
That is a common technique to simplify the equations. Then let's look at this one. Show that 15x square minus 7y square is equal to 9 has no solutions, no integral solutions.
Oh, yeah.
Hmm.
I think firstly, y is divisible by 3.
3 divides y is obvious.
So x is also divisible by 3 because like consider mod 9.
You can put y is equal to 3k and you'll get x also divisible by 3, right?
But like if they are both odd, then 15x square minus 7y square is even. So cannot be 9.
Hmm. Correct. See, you should put x as 3x1 and y as 3y1, right?
Yeah.
That will simplify the equation a little bit. So since we know x is also divisible by 3, so x can be written as 3x1 and y can be written as 3y1. Put that there, you'll get 15 into 9x1 square minus 7 into 9y1 square is equal to 9. So 9 goes away. Becomes 15x1 square minus 7y1 square is equal to 1. Right?
Oh yeah. So and that's not possible.
And why is it not possible?
Because like for any x1 and y1,
Hmm.
the difference is greater than 1.
For any x1 and y1,
The difference between 15x1 square minus 7y1 square is all greater than 1.
how do you know that is the question?
I mean,
X1 can be small and this can be quite large and the difference can be 1, no?
oh yeah, oh, yeah. Oh yeah, yeah, yeah. I was
Don't
wrong.
assume things. Just now here, if you do mod 3 here, right,
Oh yeah.
you will get minus 7y1 square is congruent to 1 mod 3, right?
So it's 2y1 square.
Huh?
So it's 2y1 square is congruent to 1.
And 7 is congruent to 1, so you can remove that. So y1 square is congruent to minus 1 and y1 square is coming congruent to 2 mod 3,
Oh yeah.
which is the contradiction. Because y1 square can only be 0 or 1, right?
Yeah.
So don't rush to the solution. Don't assume that you have got it, right?
Yeah.
You have to prove it a little bit. Okay. Fine. Then the next one is this one. Find all integer. Find all integer values of a such that the expression x plus a into x plus 1991 plus 1 can be factorized as x plus b into x plus c, where b and c are integers. Basically, if you write x plus a into x plus 1991 plus 1 is equal to this.
We'll get 1991 plus a equals b plus c, and 1991 a plus 1 equals bc.
Plus 1 equals bc. You get these two equations.
Yeah.
Fine. So now what? B plus C and BC we know. So if I wanted to find B and C, what would I do? If I suppose I wanted to find B and C here, right?
There are more than one b and c, right?
There might be more than one B and C, but how would you go about finding B and C if you have B plus C and BC?
Oh, so wait, square
Hmm.
b plus c.
Basically, you want to do B minus C whole square, right?
Oh yeah.
Is equal to B plus C whole square minus 4BC, right?
Oh, yeah.
So this will be 1991 plus A whole square minus 4 into 1991A plus 1, right?
Yeah.
Okay. So this will become 1991 square plus A square plus 2 into A into 191 minus 4. So minus 2 into 1991A minus 4, right?
Oh yeah.
So this is 1991 minus A whole square minus 4, right?
Yeah.
You're
Oh,
getting B minus C whole square is equal to this.
oh, so take the difference of squares.
So bring it to this side maybe and say 1991 minus A whole square minus B minus C whole square is equal to 4, right?
Oh yeah.
Okay. Now, how can this happen? If the difference of two squares is 4, what should happen?
Like, or wait, so I have to consider like 1991 minus a plus b minus c, and
Hmm,
1991 minus a minus b plus c.
is equal to 4.
Yeah, and it's either 2 2 or 1 4.
2 2 or 1 4. That is one way to do it. Or you can directly say that this has to be plus minus 2 and this has to be 0. Can we say that?
I don't know.
Uh, the difference between two perfect squares is 4. One of them, oh yeah, we can say that I think because the difference between perfect squares keeps on increasing, right? Like, look at the differences between perfect squares, right?
Yeah.
1, 4, 9, 16, 25. The difference keeps growing. No? The difference between two perfect squares is 1 here, is 3 here, is 4 here.
Oh,
But after that, it keeps increasing forever. No?
yeah.
One way to say that is that the y is equal to x square function, y is equal to x square function is an increasing function, right?
Oh, yeah. Yeah. I think, yeah.
And and the derivatives, the slope is also an increasing function, 2x.
Yeah.
So since its derivative is also increasing, it keeps growing at a faster rate,
Yeah.
right? Like
Yeah.
it will not slow down. The growth keeps increasing. So difference between successive squares will keep growing, right?
Yeah, and from the normal method, it's the same result.
What normal method?
Right? To take the difference.
The x minus y, x plus y factorization.
Yeah.
Okay. Okay, that is also good. So we will get this as plus minus 2 and this as 0. This as 0 means b is equal to c. So that will help us solve this one easily.
Yeah.
So you should get values of a then, right?
Yeah.
A should come out to be, I think, 1991 plus 2 and b is equal to c, and the other possibility is 1991 minus 2, right?
Yeah. So B and C are 1992 or 1990.
B and C B and C were what? B plus C was this. So 2B is equal to 1991 plus A, right? So either average of 1991 and 1993 or 1991 and 1989, right?
Yeah.
So either B is equal to C is either 1990 or 1992, right?
Yeah.
Okay. There are more questions, obviously, but we'll stop at this point. Tomorrow onwards, I think we can start inequalities if you want tomorrow.
Okay.
Inequalities we can do a little bit. Inequalities, functional equations, these things we should do. And any other topics that you want to cover, or if you want to do solved papers from your past years, you can do that also.
Okay.
So you should start doing past year papers and we can discuss those. But tomorrow we'll start inequalities. Okay.
Okay. Can you send me the recordings of these lessons?
Yeah. I'll send it to you.
Okay.
Just send me a reminder. I'll forget otherwise.
Okay.
Yeah. Okay. I'll see you tomorrow then.
Okay. Bye.
Bye.